Hello everyone, so today we are going to discuss about the SSL handshake, right? So first of all, we need to understand what is SSL and why do we need it, right? So SSL is your secure socket layer. We used to use it earlier. These days we use transport layer security and we call it TLS, right? So after SSL 3.0, we have been using TLS 1.0, 1.1, 1.2 and nowadays we use TLS 1.3, which is highly secure and it is using very strong ciphers. Okay, so basically these are the cryptographic protocols that provide security for communication over the internet, right? So what SSL or TLS does, they are going to encrypt the segments of the network connection at the application layer to ensure secure end-to-end transit at the transport layer. Okay, SSL is going to provide you mutual authentication, data encryption and data integrity. Okay, so now let's understand the handshake process, how it occurs, how we are going to encrypt your data before sending it over internet, right? And what is the logic behind it. So when we discuss about the SSL handshake process, so let's first understand this communication between the client and the server. So whenever you visit any website over internet, right, let's say you are visiting facebook.com, right? So your client machine is going to perform the DNS lookup. You will get the public IP of that particular server, with which you need to make the connection. Then your client machine is going to send the TCP SYN packet to that particular server. You are going to receive the SYN plus acknowledgement from the server, and then you will send the acknowledgement, and this is how you have successfully established your TCP connection, right? Now following the TCP connection, your client machine is going to send the client hello packet. Now this client hello packet is SSL packet. It is going to have the details of the version. It is going to have the details of the ciphers which your client machine can support. It will be having random value variable, right? And it will be having few extensions which are crucial for the negotiation process, right? Like server name indication, hashing algorithms, your certificate, digital signature algorithms, your EC curve points, right? Like this. Okay. After this client hello, your server is going to respond back with the server hello, right? Now this server hello is going to select one cipher from the list which client has shared inside the client hello, right? So client is going to present, let's say 10 ciphers, that these are the ciphers which I can support, right? So out of those 10 ciphers, server is going to pick one cipher and it is going to share it with the client that let's negotiate on this particular cipher. Then server is going to prove its identity by providing the complete certificate chain, right? So it's like this. If I want to prove my identity to someone, I need to I need to produce documents which have been issued by any central authority or any government body, right? So similarly, over internet, your websites are going to provide you the certificates, and these certificates are digitally signed by certificate authorities. So we have certificate authorities like GoDaddy, DigiCert, Verizon, right? They are going to sign our certificate, and these certificate authorities, their root certificates are already installed in our machine, in our local machine. So whenever you install any browser, you automatically install all the certificate authorities root certificates in your user browser store. Okay, similarly in your machine, in Windows machine, we have two stores. One is your local certificate store, another one is your machine certificate store. So whenever you install any browser, they are going to install all the required root certificates in your certificate stores. So when you receive the certificate from the server, you are going to perform the verification step. So you do the lookup inside this store, and if you have the root certificate installed, then you are going to validate the certificate chain which server is sending to you, right? This is the step 1. Step 2, you generate OCSP request, that is your online certificate status protocol request, to check for the revocation of the the revocation status of the certificate, right? So let's say GoDaddy has revoked the certificate from this server. So there is a location where revoked certificates are stored. So your client machine is going to reach out to that particular location with the help of the protocols, that is OCSP and CLR, right? So initially we used to use CLR, but these days OCSP is being used, right? And if the client machine is able to find out that certificate inside the revocation list, then it is going to give you an warning, right? Similarly, if certificate cannot be trusted, if certificate chain is not valid, you will get the notification in the browser itself that connection to this particular website is not secure. Proceed at your own risk. Okay, and you will get the error name why this certificate is not valid. Then server can also ask you to present your certificate, but generally over internet no website asks for the client certificate. Only in specific cases and in enterprise network, servers ask for the client certificate, right? So let's say you want to deploy remote access VPN portal. So in that case, your portal can ask for the client certificate, so that it can make sure that the machine which is trying to gain the network access belongs to that particular enterprise. Then you will get the server hello done message, right? And after that, client is going to provide the client certificate if server has requested. Otherwise, client will share the key exchange, right? So if client is going to present the certificate, then server will do the verification. If server has not requested, then this step can be skipped, right? And client is going to share client key exchange. Now what is this key? So it's like this, client generates pre-master key, right? Encrypts that particular pre-master key by using the public key which has been received inside the server certificate, and sends it across to the server, right? And server can decrypt this particular exchange message by using its own private key to take out that pre-master key value, right? When both the ends have these pre-master key value, then they generate master key, right? Master keys are getting generated by pre-master key and random variable values, right? Once they have generated the master key, then they generate shared secret on both the ends, right? And this is how your shared secrets gets generated on both the sides, right? And once that shared secret is generated, client is going to send the encrypted message, right? And server will do the decryption, and similarly server is going to send the encrypted message. And when both the parties are able to encrypt and decrypt the messages, then they will start negotiating. They will start encrypting the actual HTTP stream, which is getting received from the application layer, right? And nobody can decrypt that particular stream. Only client and server can do that. Okay. So after this client key exchange, let's say when the encrypted messages have been shared across client and the server, and if they are facing any issue, then this message comes into the picture, that is change cipher spec, right? Which says that you need to lower down the TLS version, we are having issues, right? So whosoever is facing issue, they will send the change cipher spec message, and they will provide the content and ask the another peer to lower down the TLS version. Okay, by default, if you take the Wireshark captures, you will see that this message is there, but it is empty message, right? Until and unless there is a need to lower down the TLS version, because the cryptographic algorithm, whatever you have used, they are facing challenges in generating the keys, and they are not able to decrypt the messages, right? So your encrypted messages will be sent across, and if successfully we are able to encrypt and decrypt, then we will start sending our HTTP stream by encrypting it with the help of the shared secret. Okay, so let's quickly recall what we have discussed. So when server certificate came to us, we did the verification, right? And then we have encrypted our pre-master key with the help of the public key which we have received inside the server certificate, and we have sent it across, right? On the other hand, server has taken out that pre-master key by decrypting that message with the help of the private key, right? And now both the parties will generate the master key by using pre-master key and random variable value which they have shared inside client hello and server hello. And after that they will generate the session keys by using this master key, right? And once this master key has been this session key has been generated, it will be used to encrypt and decrypt the following HTTP stream. Okay, if there is a problem in these encrypted messages, then either client or server, they can request to lower down the TLS version with the help of the chain cipherspec message. Okay, so let's understand how this pre-master is being shared and how we are able to generate the shared secret on both the ends. Okay, so it's like this. Let's say this is your client, this is your server, and we have started the negotiation. Once you have received the server certificate chain, you have generated the pre-master key. Let's say pre-master key value is 5, right? Now what you are going to do, when you are transmitting this pre-master key, you have encrypted this message by using server's public key. Okay, now if somebody is taking capture, they cannot see what is going inside because they need server's private key to decrypt this packet. So only server can decrypt this packet. Now server will take out the content and the key value is 5. Now they both will do the mathematical computation to generate the keys. Now client will perform the mathematical computation. So first master key will be generated by using this 5 plus random variable value which has been shared inside client hello. Similarly, here server will generate the master key. So by using this pre-master as well as random value which has been shared inside the client hello and server hello packets. Once your master key is generated, then you will generate the shared secret key by using the master key, right, on both the sides. Now this shared secret will be same on both the ends. It should be same. If it is same, then only you will be able to encrypt and decrypt the messages. Otherwise you will face problems. So before sending actual HTTP stream, we send encrypted messages just to check out that both the ends are able to successfully encrypt and decrypt the messages. If they face problem, then we will use chain cipherspec message to lower down the TLS version and renegotiate. Okay, so now let's do the verification with the help of the Wireshark. So if you see, you can also do this activity. It is quite normal. Just visit any website, turn on your Wireshark captures, visit any website and filter out the stream. So you will see that initially TCP 3-way handshake will happen, right? And right after that, your client machine is going to send the client hello packet. If you open up this hello packet, so in layer 7 info, you will see that it is going to have this random variable. It is having some value, then complete cipher list which it can support, right? And then there are multiple extensions. So server name is there, which will be having your domain information, right here we have made the connection with the IP address, but you will see domain, Facebook, YouTube, wherever you are visiting, right? All these extensions, right, they are having necessary information. Okay, so let me just show you, like if you see this signature, there is one signature algorithms, so you can see the hash algorithms which client is going to use, right? Similarly, you'll get the acknowledgement from the server. It is the normal TCP behavior. Then these messages, server hello, certificate, server hello done. So generally the packet length is going to be 3000 to 4000 bytes, because it is going to receive share the entire certificate chain. So it comes in fragments and then reassembly done at the client end to reproduce this particular packet. Okay, so now it's like this. After reassembly of the packet, you will see server hello. Inside server hello, you will see that which particular cipher has been selected by the server, from the previous list which was shared by the client, and the random variable value, right? That's it. Then in certificate, you will be able to see the certificate details. Inside the certificate, you will be able to see the signature of the certificate, serial number. You will be able to see the public key of the certificate, right? Now this public key will be used by the client to share the pre-master. So this is the public key. You can see details here, right? Now in server hello, you will see that in server hello done message, there is nothing. It is just the notification sort of message, right? And you will get the client acknowledgement packet, and right after that you will see client key exchange message. Now in this client key exchange message, your pre-master key will go, right? So if you open it up, you will see pre-master secret encrypted. If you open it up, this is the encrypted message, right? So only server can decrypt, because server is having the private key, right? And then it also sends chain cipher spec. So right now it is empty message, right? But if there would have been any problem, it will ask server to lower down, or similarly server will ask client to lower down the TLS version. Then encrypted handshake messages, right? So they send the encrypted messages so that both the ends, they can perform the encryption and decryption with the help of the shared secret which they have generated. To check it is working properly, they have generated the same shared secret, okay? And then similarly you are going to get the same message from server that your chain cipher spec, right? So it is empty. In case there was any need, it will contain the required information, and then they will lower down the TLS version. Then encrypted handshake message. So it is going to have all the necessary details, all the messages, and then client is going to perform the decryption, take out the message. If client will face any challenge, then with the help of the chain cipher spec, they will lower down the TLS version. Once these encrypted messages have been interpreted, after that we will send the application data. Now this application data is nothing but your HTTP stream. So HTTP GET packet has been encrypted by using shared secret, right? So now you can see that nobody can see what you are transmitting over internet. So your application layer data is encrypted, right? So whenever you make connection on port AD, you are sending it in plain text. But if you are making connection on 443, and if you have validated the certificate, then you are making a secure connection, and you can communicate with that particular website securely. Nobody can steal your information. And once you have communicated, if you would like to terminate your connection, then we will follow the TCP 4-way handshake to terminate the connection. So this is how we make the connection secure over internet. Similarly, let me show you certificate. So you can see connection is secure, certificate is valid, certificate path, right? So this is the end website certificate. This is the intermediate certificate authority which has signed this particular end certificate, and then this is the root certificate which has signed this particular intermediate certificate. In details you will be able to find it out, what is the serial number, what is the thumbprint of this certificate, and this root certificate must be installed inside your certificate. So if you type certificates, so here this root certificate should be present, then only your browser will say that connection to this website is secure. If you don't have your root certificate installed in this particular store, then your browser will give you the notification that connection to this website is not secure. Okay, so that's it. If you have any doubt, you can let me know, right? And you can post your queries in the comment section. There will be a course for TAC Foundation, right? So if you want to step in TAC environment, there will be a course which will help you to analyze the packet captures in Wireshark, and it will help you to understand the protocols, right? And it will help you to build your troubleshooting skills, and you can step into the network security. Okay, so thank you for your time. Thanks for the watching. Stay connected.